previous lessons that I've done have been on Ohm's law and resistors in series, and you can see those on earlier videos. So resistors in parallel. Resistors in parallel is something that you will come across when we do electrical work and we do design. And testing. There are a lot of things where we have resistors in parallel. We use the term parallel path quite a lot when it's going to resistors. So this is something that you will do in inspection and testing. So resistors in parallel, how we add up resistors in parallel, we add them up with this equation. RT, as I said to you last week when we talked about series, is the total. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, if you've got your calculators that we had, we will go through and we will discuss how to do this. But if you have got your calculators, and I was trying to download a calculator emulator earlier so I could do this, but it doesn't work on a Chromebook. You have a button in the top corner, and it's very easy that you can use these calculators just to simply do this. As I said, it's good to know the fundamentals, but actually in the real world, a lot of you will just use your calculators, and you're allowed to use your calculators. So we've got an example here. We have 3 resistors, a 9 ohm, a 12 ohm, and an 18 ohm resistor, all connected in parallel. So we have to add those up. So we have 1 over RT is equal to 1 over 9, plus 1 over 12, plus 1 over 18. To add up fractions, we have to find the lowest common denominator, which is 36, which means what number does all the bottom numbers go into? Yeah. And then we can look at this. So 9s go into 36, 4. So then we have 4 over 36. 12 goes into 36 3 times. So we have 3 over 36. And 18 goes into 36 twice. So if we add that up, we end up with an answer of 9 over 36. But the thing to remember here is that is 1 over RT. That is 1 over RT. And I can just get my little pointer here, if I like. So you've got this 1 over RT. So, I hit the wrong button there. That was not what I meant to do. Chromebooks aren't as good as a PowerPoint presentation. So you've got 1 over RT. So if you turn that back around, so you've got 9 over 36. If I can get rid of this, I'm trying to get rid of this thing here. So you've got 9 over 36. So you have to invert it. You have to flip it to get your answer, which then gives you 36 over 9, which gives you an answer of 4 ohms. So the total resistance in the circuit will be determined by the current flowing in the circuit. So we'll go into that in a second, but I just want to go through here. So what you can see is you have a 9 ohm, a 12 ohm, and an 18. But when you add them all together, you get a much smaller resistance. You get a much smaller, considering you've got an 18 ohm resistance, but when you add them together, you get 4 ohms. So this is more of a real example when you can have a look at this. So you've got a 45 ohm, a 90 ohm, and a 30 ohm. So once again, we can do the common denominator of 90. So we've got 3 30s into 90, 1 90, and 45 goes twice. So we add them together and we get 6 over 90. I don't know why this horrible thing keeps popping in there. So once again, 1 over RT is equal to 6 over 90. So we have to then, to get our answer, we have to invert it again. So we get 90 over 6. So 6 into 90 gives us 15. So I'm going to go back one step. The interesting thing here is if you had 3 resistors of the same size. So say I had 3 resistors that were 30 ohms. So I had 1 over 30, 1 over 30, 1 over 30, and I add them together. I have 3 over 30, if I inverted that, I would have 30 divided by 3. So if you have 3 resistors in parallel, or 4 resistors in parallel, but all the resistors are the same size, you literally divide the size of one of those resistors by the amount of resistors. So if it was 4, if it was 5, as long as they're all the same size, it is really quite easy to work out. You just divide it by the amount of resistors you have in parallel. This is a different example, and this is we can calculate it. But what I would always say to you is just use your calculators for most of you anyway. But here you've got 2 resistors. You've got a 6 and a 4 ohm resistor. And what they're saying is if you times R1 by R2 on the top and you add R1 by R2 on the bottom, it will give you 6 times 4, 24, plus divided by 6 plus 4, which is 10, gives you 2.4. But as I said to you, when it comes to the real world and a lot of the stuff, especially when we go into design and everything, we'll just use our calculators, and hopefully I can get a little emulator and we can do this next time. Now, we looked at Kirchhoff's law last week, which was about in series, which was the voltage. So this is Kirchhoff's current law. And this is the sum of all current arriving at a point must equal the sum of the current leaving. So in this case, we've got 7 and 5 going in, which gives us 13. So then what we have is we have to have that coming out. So we have 8, 3 and 4 coming out. So if we go into this little equation, so we have a resistor R1, 4, R2, 6 ohms, and R3, 12 ohms. And we have a voltage of 12 volts. And we need to find out what the current is flowing through each of those resistors. Now, when we look at this, we have 12 volts. So the potential here is 12 volts. So we have 12 volts going from this point to this point. We have 12 volts from this to this, and we have 12 volts to this to this. So the basic thing to remember is in parallel, the voltage is the same. The voltage is the same across each of them. So then what we do is we use our Ohm's law, and we do a little triangle, V over IR, and we have V, 12 divided by 4, which gives us 3 amps flowing through here. We have 12 volts divided by 6, so we have 2 amps flowing through here, and then we have 1 amp flowing through here. But obviously, if you've got 1 amp here, 2 amps here, and 3 amps here, we need to work out what the total ampage is that will be coming through this circuit before it splits off. And then we just add those together. So this is a different example. So what we have to do here is, first of all, we work out the total resistance of the circuit. So we've got the total resistance of the circuit. We add them all together. So we have a common denominator of 12. So we have 3 over 12, 2 over 12, and 1 over 12, which gives us a total resistance of our circuit of 2 ohms. So we have 2 ohms. So by using Ohm's law, we have 6 amps flowing through the circuit. Yeah. So then we've proved the Kirchhoff's law. So it's just a double check. We can work it out individually, 6 amps, and then we can work it out as a total. So a lot of these handouts and the worksheets that I give you will be regarding that, where we will just double check our work at the end by using Kirchhoff's. So I'm just going to ping out of here, and I'm just going to stop recording.